Hi, welcome to my channel. Today we'll be talking about matrix inverse of 3 by 3. If you need to see the video for matrix inverse of 2 by 2, just watch my previous post. If we need to find the matrix inverse of 3 by 3 in any matrix, this is a 3 by 3 matrix because it has 3 rows and 3 columns. So we'll call that a 3 by 3 matrix. Now, for us to find the inverse of this matrix B, we use the formula B inverse equals to 1 over determinant of B times adjoint of B. Now, how do we find the adjoint of B? For you to find the adjoint of B, you need to get the cofactor, then transpose, and find the minor of each element. Now quickly, let's look for the determinant of B. Now for us to get the determinant of B, all we need to do is just to use our cofactor on the first row or the second row or the third row or the first column or second column or third column. Okay, now let's use the first row. So I put my cofactor, which is plus, minus, plus. For the first one, which is plus 4, we have plus 4 will delete the first row and first column. I'm left with 8 minus 1, 2, and 5. The next one is minus 1. So minus 1 will delete the second column and the first row. So I'm left with 3, minus 1, and 5. The last one is plus 7. Plus 7 will delete the third column and also the first row. So I'm left with 3, 8, 3, and 2. So what do we have here? For us to find the 2 by 2 determinant, we need to multiply the leading diagonals and subtract from the opposite diagonals. So what I'm saying is, these are the leading diagonals, 8 and 5. So 8 times 5 will give us 40 minus the opposite diagonal, which is minus 1 times 2. And that will give us minus 2. So the next one is minus 1. This minus 1. I have my minus 1 here. So also the leading diagonal is 3 and 5. So 5 times 3 is 15. I have my 15 minus my minus 1 times 3, which will give me my minus 3. So we move to the last one, which is plus 7. I have my leading diagonals, which is 3 and 2. So 3 times 2 is 6. Minus my opposite diagonal, which is 8 times 3, and that will give us 24. So 40 minus 2, that's 40 plus 2, which is 42. So I have 4 times 42. I have my 4 times 42 minus 1. 15 minus 3, that will give us 15 plus 3, which is 18. So I have plus 7. So 6 minus 24, which will give us minus 18. I have my minus 18 here. So 4 times 42 will give me 168 minus 18. So this times this is going to give me my minus 7 times this will give me 56, 6, 5, 7, 8, minus 86. So if I do my calculation here, I'm going to get 168 minus 18 minus 86. I'm going to get my determinant of B to be equals to if you do that correctly, you're going to get 24, right? I think that's correct. 64. Now, since my determinant of B is 64, that means I've gotten this, I need to find my adjoint of B. How do I get my adjoint of B? Remember I told you that you need to find the cofactor. After the cofactor, you transpose. After transposing, then you find the minor. Quickly, I'll just tell you how to get my cofactor. Cofactor for a 3 by 3 matrix is your plus, minus, plus, minus, plus, minus, plus, minus, plus. So you are just putting the signs on each element. Okay, so cofactor is plus, minus, plus, minus, plus, minus, plus, minus, plus. So all we need to do is just to put the signs on each element. So I have this to be plus 4, plus 4. Next one is minus 1, plus 7, minus 3, plus 8, minus to give you plus, so I have plus 1. Next one is plus 3. Next is minus 2. And the last one is plus 5. So this is my cofactor for this matrix. Next, I need to transpose. How do I transpose? To transpose is just to change rows to column or columns to rows. Okay, that's how you transpose. Now, for me to transpose, let me use this side. Transpose. Now, if I change my columns to row, I'll have this to be 4 minus 3, 3 minus 1, 8 minus 2, 7, 1, and 5. So this is my transpose. The last thing I need to do is to find the minor of each of the elements. And how do I find the minor? So for you to get the minor, you need to use the one you transpose. So this is the one I transpose, so I'm going to get my minor from that. Now for you to find the minor is just to delete the rows, first row and first column. Then you have a 2 by 2 matrix, so you find the determinant. That determinant will replace the value of your first element. Now I'm just going to do one for you, so and I'll quickly write the minor for the rest. So you try it out to get the minor for the other ones to see if it's correct. Now let's find the minor for the first one, which is 4. Now for us to get the minor for that, which is 4, let me use this side. For me to get the minor, for the first element 4, I have to delete the first row and first column. If I delete that, I'm left with 8 minus 2, 1, and 5. So I have 8 minus 2, 1, and 5. And this will give me the determinant for this is 40 minus 2, which is 42. So all we are trying to do is to replace this 42 in the position of 4. Okay, so you do that for the rest of the elements. So for minus 3, which is the second one, you delete this row, this column, and this row. So you'll be left with minus 1, 7, minus 2, and 5. So you find the determinant for that and replace with the minus 3, position of minus 3. So you do that for the rest element and see what you get. If you do that correctly, we're going to get our minor to be So our minor or our minus to be, first one will take 42, which is the one we just finished. 42. Next one will take 9 minus 57 minus 18 minus 1, 25 minus 18 minus 5, and 29. So this will be the minor for this matrix B. So if you try it, you get all these values for the minor. Now if this is the minor, minor is also called, after you've gotten your cofactor, you've transposed, and you've gotten your minor, then you know that that is the same thing with your adjoint. Okay, so remember our formula is B inverse is equals to have B inverse is equals to 1 over determinant of B, and remember our determinant is 64, 1 over 64 times our adjoint, and our adjoint is now this. So we have 42 9 minus 57 minus 18 minus 1, 25 minus 18 15, sorry, minus 5, and 29. So this is our B inverse. Okay, if you like, you can still open up the bracket with your 64, okay, or we can leave it at this position. Okay, so this is your B inverse. If you like this video, you can subscribe to my YouTube channel to watch more videos. Thank you.